Well, welcome to the channel. My name's Tel, and hopefully I'll be able to make your day just a tiny bit more interesting and hopefully a lot of fun as a result of you watching this video. So today I'm going to take you through the journey I took to build a once extremely popular gardening fair or drinking game. So the object of the game is for the user to move a wand which has a small wire at the end which goes around the Buzzwire and attempt to cross the length of the Buzzwire to the other side without making contact. If they do, the buzzer is sounded and they lose that round. But we're not settling for a buzzer and battery, which is the standard go-to when somebody builds one of these things. Oh no, we want to go much further than that. In our game, we want competition. We want pressure. And most of all, it will be able to occupy your kids, wow your mates when they come over for a drink, and more. But before we get into that, let's have a quick look at some of the background information regarding this game. So, the Buzzwire game is over 70 years old as a concept. Originally a buzzer and a battery and a wire. Have you ever seen this before? Probably a tombola or a fete or county fair or fairground. A few weeks ago I built a prototype and used what's called the Agon Lite, which is a new retro computer. I used this game or something similar to what you're looking at on the screen now to test the output pins and input pins of a Agon Lite. But I really wanted to build this game anyway, so what I decided to do is go and do it on another platform in order to do all the things that I wanted to do, have it in a really nice package. So we'd like to maintain a small footprint, something that would make it easy to move about, storable, nice to look at. It would need to use a commonly used power source, like a USB, for example, so that's what we're going to do. It needed to be standalone, with the exception of the power. Okay, so we didn't want a screen to be tagging along with this thing or a computer keyboard. It just had to be in front of you and just work. So to give feedback to the user, we need a usable but fairly small color display unit, and you can see it in the middle there. We need a countdown timer, and the reason for that, we want to pile on the pressure as much as possible on the players so they get all nervous and make a mistake. That's the idea, so only the coolest players win the game. We needed some sort of computer to keep track of the game. We needed sound, and you can see to the right of the little control unit there that there's a speaker. It needed to look a bit better, so hopefully it does now. And then we need to go and write some code. So that's what this video is all about. So what I'm going to go on and do now is to show you a little bit about the base design, and then we'll progress from there. Don't worry, because I'm not going to bombard you with lots of code. For the people who know how to write code, I'm going to provide them with the code and a link in the description section, which they can get to afterwards. You don't need to know how to write code in order to complete this project. All the stuff that you need will be available. But if you want to have a go at it, whoever you are, then absolutely just go for it. Right, so with the base, I thought I'd give you the dimension so that you can see where everything's positioned should you choose to make it in that way. So continuing with the base, we've just got a very simple wiring diagram. So this is clearly demarked as the display, and there are the decals there telling you what those things are. I've used these colours, but you don't need to. You can use whatever you want. At the bottom we've got a representation of the controller itself. So this is all the controller really, but it's just showing you the parts that you use to make connections with the tabs, left and right, and the Buzzwire itself. But again, you don't really need to know too much about these things. All you need to do is go and buy them. If you can solder it, connect it up together, and you're handy in that way, then that's fine. This is a Arduino Nano. So for the purposes of this video, this is just a small microcontroller rather, on a chip, and it's quite small. It can do all sorts of things. We've got input-output pins that we can use. We can read information coming in, we can put information out. So if you look at the controller at the bottom, the controls itself, into pins labeled D0, 1 and 2, these are going to be data inputs, and we're looking at those pins to find out what's happening on the controller. We've got a reset facility here, so this is a push button on the left hand side, and we can reset this thing and start it up again. We have a settings push button going in here on the ground to A14, and if we use these two together we can create a change in the way that this works. Currently the settings only turns off countdown timer, so that's what that's for at the moment, but I do intend to do some updates to allow to select between 2 players and 1 player, and also to select the length of the countdown timer. And this is just information to display things on the screen, so the code, when the code is running, it wants to tell you what to do. It will just put information on the screen and you'll be able to read it. So over here we've got the audio side of it. Now initially I had this tiny little 8.5 watt connected straight into D6 to ground, and that worked fine, but I was aware that it is probably exceeding the current limitation of this chip, so I decided to do something else with it. And we just have this small configuration of resistors and capacitors and a transistor to take the load off this chip and to make it come through this transistor here. So you can read for yourselves what those things are. This electrolytic capacitor, this is just a ceramic disc capacitor, and there's this mysterious diode which is going between the negative side of the speaker and the 5-volt line. The reason that is there because when we take the voltage off the speaker, when it's created a tone, but when the voltage comes off, you get what you call back EMF, which is a voltage created when the field collapses and it puts voltage in here. This is to stop any damage being done by that. And then there's some small current limiting resistors. There's a 220 into this base of this NPN transistor and a 47 in series with the speaker. It's loud enough, it's not very loud, but we don't want to take too much current because this is on a USB interface, and this is also taking power, this is taking power, and this is taking power too. So I think the spec for USB is about half an amp, but most hubs only actually do about 350 milliamps. It's still probably quite a lot below that, but it's better to be a little bit on the economic side. So that's what this is. How you build it is up to you. What I did was took a bit of strip board or Vera board, whichever you want to call it, and I just built it on that because there's not much going on, and then everything comes in to the control box and it just gets wired in as per this diagram. So that's really all I want to say about that. In terms of cost, this is the Arduino Nano is probably somewhere in the order of about £6 or £7. Display is about £5 or £6, and the speaker, maybe you got one sitting around in an old radio or something, or Amazon, £3 or £4, maybe. So all in all, you're around about £20-25. You know, in terms of the controller here, this cost me absolutely no money at all. Because I had some wood and I had an old coat hanger because that's what we use. So if you got an old wire coat hanger, you just unravel it, straighten it up, give it a sand down with sandpaper, and then you can use it to poke through these holes. So coat hanger wires somewhere between 1.5mm and 2mm, I think. That's the drill size I think I used, was I think 2mm, and it went through fine and worked okay. And these were just a couple of washers I had in the drawer, really. The box, I probably paid about £1 for the box, £1.50 for the box, I think. And then these pieces of electronics here, a couple of capacitors, a couple of resistors, and a transistor. I already had that, so it didn't cost me anything anyway. So the next thing to do is to download the code and load it into the Buzz game. So if you are going to build this, then you'll need the software that goes with it. So this URL you will find in the information section for the video, and if you click that, you'll go to Tells Bench Buzzwire game, and you'll see there are 2 directories and a file. So the installation file is just some useful information on how to install it in your IDE. Just read through that and make sure you comply with it. The only thing that I'll draw your attention to is these libraries that are required. Chances are this one and this one will already be there because they're so ubiquitous, they're everywhere, that it's probably already installed. Any RTTTL is what you need to make the sounds on the game. So you just need to make sure that's installed. In the documentation, you've got some extra information, which is a picture of you've seen this in the video anyway, this is the dimensions for the buzz base and some explanation about that, and the Nano buzz schematic, which is the circuit diagram, the wiring diagram. Additionally, I've added a shopping list, which are all the things you need information, that's the code that you require. So there's your .ino, that's your main script, if you like, for the Arduino IDE. License obviously, mydisplay.cpp and mydisplay.h, so they'll need to be in the same directory. Okay, so welcome to the demo. So here's our little game. I've just allowed it to reboot. As you can see, there's a shameless plug there and a request for a like and subscribe, which is very important to me. To start the game, you have to press any tab, so we just click that. So it's going to start up the timer in a minute. So I've got to try and get to the other side, and I've failed miserably already. So I'll go over there and I'll press that. The colours on the display are not as they appear to me. Somehow it's looking a bit washed out. I think it's the lighting, but trust me, it looks really good. So I better shut up and try and... I'm not doing very well here, am I? As you can see, it's got losses for both sides because it's in a two-player mode at the moment. Right, let me go a little bit slower now because I'm inhibited by the camera, that's my excuse. So I'm going to have to turn this very slowly. So easy to make a mistake. I'll tell you, that's really annoying. And I'm running out of time. I've got 27. I can't really see the distance at the moment because I'm at such an angle, but I think I've made it. And I've won. There you go. That's telling me I've won. So there's our score sheet. Player 1, player 2. And I've failed, so it's going, go on, go all over the other side, alright. Right, so let me just demonstrate something. I'm going to press the reset button down, press the yellow button down, and then I'm going to let the reset go. When the game starts, we won't get a timeout this time because I've turned it off. So as I said earlier on in the video, I'm going to be adding some more options in here with a little menu. I haven't quite done it yet. This all takes time and I really want to get the video out, but I will put an update in shortly when I've done it. So you can see there is no timeout there. So for somebody who's really slow or who can't possibly do it in 60 seconds, then you can obviously go ahead and change that in the code, or you can turn it off. But what I intend to do is to have full skill levels. So when it's in the insane mode, you only get 10 seconds. So you got to really be sharp and quick. But of course, the size of the loop matters, and the configuration of this Buzzwire here also matters. So it's not a simple matter of skill level against time, it's the whole configuration of the machine. So you can configure it any way you want. This happens to be a sort of sinusoidal wave configuration here with some distortion in it, maybe some harmonics possibly. But it could be a hand, it could be any shape that takes your fancy really. but don't make it too easy, otherwise it's not worth playing. So we can play in 1-player mode now, and we can play in 2-player mode now, but you'll have to change the code at the moment to swap it from 2-player. So I've left it at 2-player by default, because I'm assuming that's the most likely use case of it when you've got 2 kids or 2 friends who want to play. They want to play against each other. But that can be changed, and I'm going to make it change on there. So that's the plans for a little bit onwards from now. Just to point out, which I didn't point out, these shrink sleeving here and here forms an insulation between the Buzzwire and obviously the tabs, which is necessary. Anything will do, actually, a bit of insulation off a power cable or some shrink sleeving if you've got it. But it could do so much more. Absolutely could do so much more. You could even set it up, not with this chip that I've got in there, but you could set it up to play over the internet, so you could have remote sessions with someone else, which is taking it kind of to the extreme, but those are things you could do. These videos, although it may seem simple and the demo is quite short, do take a lot of effort to put together. So I really would appreciate it if you're not a subscriber, if you'd like to subscribe to my channel so that you can see projects like this or different work that I've been doing. And just as importantly, you can share the video with your friends. That gives me more views and likely more subscribers. I hope you enjoyed the video and you'll like and subscribe. And I will see you next time.
It's gonna be alright.